everyone. I'd like to talk about the migration of microservices, cloud to cloud, to support Merpay's anti-file efforts. I'm the engineer manager of the Merpay TnS Trust Safety Team. I'm Asano. Let me introduce myself. I joined Merpay in December 2019 as an engineering manager. And I have been working in several teams concurrently, and now I am working with the TnS team dedicatedly. Today, I'd like to share with you some of the changes in our anti-fraud system since I started working on TnS. This is the agenda for this session. Introduction, migrations, issues and measures. So 3 parts. So I will introduce team and system and why we migrated, and then what are the problems that we faced and how we handled them in the migration project. So now the introduction. First, let me briefly introduce my team. So we are the Merpay TnS Trust and Safety Team responsible for Merpay's anti-fraud measures. And we are engineering to deal with the ever-increasing flows to ensure our customers' safe and secure transaction with Merpay. Our teams uses 4 different systems. This table shows each system and its history. First is the rule-based fraud detection system. This is a system to set rules by query to detect fraud. We use a product called Splunk. When we started up, we used to install and configure the system on AWS ourselves. But last year in 2021, we moved to a service called Splunk Cloud. Next is the data aggregation system. This is a system that collects data from a group of services within the Mercari group, such as the Merpay and Mercari shops. We have several microservices running, and the batches are also running. This was originally running on AWS as well, since it was often linked to the rule-based fraud detection system I mentioned earlier. These are moved to GCP this spring. We are moving them to the same infrastructure as other Merpay microservices. And here is the operational system. This system is part of the internal tools used by the CS operation team, which is the team that monitors fraud on a daily basis. This was also migrated to GCP this spring, just like the data aggregation system. And finally, the real-time fraud detection system. This one has been built with the same configuration as the other microservices of Merpay on GCP since the beginning. So I won't talk about it today. So since I have also introduced the mechanism of this real-time fraud detection system here in Merpay Tech article this spring, so I will share the link to this article later. As shown in red in this table, our team has gone through 2 different cloud migrations over the last year and this year. So now I explain why we migrated these systems. Okay, the first migration. The first migration was the rule-based fraud detection system, which is the Splunk. This happened last year. So we migrated Splunk cluster built on AWS to a service called Splunk Cloud provided by Splunk. At the beginning of our service, when Merpay was launched, we chose to build our own service on AWS for the reasons that Splunk mainly guaranteed operations on AWS and also for the flexibility of building the service. However, as we continued to operate the system, both AWS and Splunk were mainly used by our team, and the operational load increased. Specifically, infrastructure costs. The cost of managing dozens of high-spec instances that make up a cluster, and the maintenance costs. Both of these services require a certain amount of expertise, and it is necessary to keep the engineers who can deal with them. Also, and the difficulty of maintaining high standards for scalability and security, which are required in financial services. So it was difficult to keep the high standard only by ourselves. We thought we could reduce such burdens by migrating rule-based focus, excuse me, by migrating the rule-based fraud detection system to Splunk Cloud. So that's why we migrated it. So the second migration. The second migration was to migrate data aggregation systems and operational systems on AWS to GCP. This happened this year. The reasons for the migration are just like the first migration to Splunk Cloud, as I mentioned earlier. So we have the same maintenance cost issues. Also, unlike Splunk, these systems are microservices and the batches that are developed by ourselves. Usually, mail-based backend team develops microservices by leveraging the tools provided by our in-house specialized team of SRE and architects. However, our team has been developing the microservices on AWS by ourselves. So therefore, we were not able to utilize the tools provided by in-house team, and therefore we went to the trouble of developing equivalent tools by ourselves. So we decided that we should not reinvent the wheel and that we should utilize the cross-functional tools, which was the second reason for the migration. And especially in recent years, the urgency of the priority of anti-fraud measures has increased. So we have decided that we should focus on the development and the adoption of the anti-fraud measures, which is supposed to be our main focus. So this is why we decided to move to GCP. So now I'd like to continue with the issues and the measures. So I will talk about the issues we faced in the project and how we handled them. As issues, we had 3 issues that we faced: priorities, directions, project management, and uncertainty. So I will talk about each of these issues and how we handled them. Okay, the first, priorities and directions. Each migration project is a project that takes about a year. In the midst of rapidly changing circumstances, both inside and outside of the companies, In order to constantly run the projects that take a reasonable amount of time to complete, it was necessary to constantly maintain priorities and directions. To be specific, at Merpay, in each quarter, product organization regularly review which projects to be executed. In other words, priorities shift due to the changes with the companies. Also, especially after pandemic, as online purchasing behavior increases, fraud is also increasing. So we, the anti-fraud team, have heightened urgency and priority of our tasks, which is a detection of the fraud. So this is about a prioritization due to the external factors. So finally, as a direction, to what extent do we migrate our system? And upon the migration, shall we reorganize our systems? We considered these factors as well. These are the actions we took. As for changing priorities within the company, we need to make sure that the project does not stop. We presented the needs and current status of the project and the risks in case of stoppage. By doing so, we maintain the priority of project to keep the project running.
Regarding the implementation of fraud countermeasures due to external factors, we roughly separated our members into two groups, those engaged in fraud countermeasures and those participating in the migration to avoid delay in fraud countermeasures. At the same time, we increased hiring and enhanced the entire team. In judging a direction, we try to take a balance between migration and re-architecture by organizing their priority levels. We considered items that cannot be substituted at the destination or that would certainly require a configuration change must be in the top priority to be replaced and designed. There are some that would be more efficient from a development and operational standpoint to consolidate after the migration through it, although it was possible to keep the same configuration at the destination. They were considered nice to have, and we made a comprehensive decision based on the development and operational cost of migration, project schedule, and others. Next is project management. This migration project has been managed by the cooperation of team of engineers and engineering managers. Migration project to GCP was broadly divided into two types of systems, data application and operational systems, with microservices and patches running across more than a dozen repositories. More than one engineer was assigned to these systems, and the project involved more than 15 engineers in total, including database and other infrastructure building, as well as consideration of re-architecture. From the beginning of the construction of these systems, there were areas where the overall picture of the system and its dependencies had become unclear, and they needed to be organized. At the beginning of the project, we set up some phases so that the migration could follow the phases. However, some areas did not proceed as we originally planned, and we had to review the phases and the scope of work. Each was handled in this way. In the beginning, the entire team gathered to check the progress to manage tasks. But it was hard to see the progress in individual systems, so we changed the way so that each system gather and check progress, making it easier to see details and obstacles. When we approached a phase that required system integration, related teams gathered to check progress together, changing the granularity of the progress checks as the status changed. Before moving on to the creation of design documents for each system, we created a design document for the entire migration to share the total system image and organize dependencies. For the organization of dependencies, we asked a specialist to focus and identify the dependency elements of each system that would be necessary for phased migration. Since there are more than 10 systems, we made a plan to migrate them in phases, but we did not stick to the initial plan and move on with review and modification as the development progressed. For example, the original plan was to complete the database and data aggregation system migration by the end of the year. But since we had difficulties in the database migration verification, we made this top priority and canceled the year-end migration. This shift in schedule had an impact on the migration plan through the spring. Therefore, the plan was revised accordingly by identifying and reviewing the scope of the system to be covered, reviewing the scope of the re-architecture. Final point is dealing with uncertainty. It is about how to reduce uncertainty and deal with it in order to increase the probability of success of the project. There are 3 points here too. First, the need to detect and understand the state of high uncertainty. Next, problems that remain highly uncertain due to their difficulties. They need to be addressed as early as possible, as delayed response can have a significant impact on the progress. Thirdly, problems that remain uncertain because they are difficult to reproduce due to environment factors or problems that can only be identified in a production equivalent environment need to be understood and resolved as much as possible in advance to avoid troubles at the timing of migration and post-migration. How did we respond to each of these? There are several ways we detected and understood the state of high uncertainty. First, when we lined up the tasks for each system, we checked to see if there were any tasks that were obviously too few or tasks that had not been identified. In addition, although we did not make detailed estimates for each of the tasks, we always made sure that there were no tasks that were completely unforeseeable for the engineers in charge. Then, during the coordination phase between systems and microservices, we checked for any discrepancies in recognition between the respective system team or if there were any areas that were left out of their responsibilities. Highly difficult problems. We also had a team's tech lead assist us in this area, and when a difficult problem was discovered in each system, the tech lead was immediately assigned as a priority to help us find a way to resolve the problem. In particular, Midway through the project, two tech leads were assigned so that the tech leads could cooperate each other to deal with any problems that might occur simultaneously in a wide range of systems. Lastly, environmental factor. Our system handles a lot of data, so we prepared an environment equivalent to a production environment. We then carefully performed load and data integrity verification on the production equivalent data and focused on ensuring that the data would not be affected by the migration. In addition, we repeatedly rehearsed the migration procedure and cutback procedure in case of problems in order to improve the accuracy of the migration process. In this way, we, Merpay TnS team, have been able to improve our anti-fraud infrastructure over the past 2 years by migrating between two different clouds despite facing multiple problems. Finally, summary. At the beginning of this session, I introduced the Merpay TnS Trust and Safety Team, its system configuration, and history. Then I explained the two types of cloud-to-cloud migration in the past 2 years and why we did it. Finally, I covered the three problems we faced in the migration project, namely priority and direction, project management, and uncertainty, and how we dealt with each of them. In the end, these are the references for our team's articles. Those are the links to the articles introducing our team, rule-based fraud detection system, and real-time fraud detection system, which I did not discuss today. I hope you could take a look at this page. This is the end of my presentation. A story about cloud-to-cloud migration of a group of microservices supporting Merpay's anti-fraud measures. Thank you very much for your attention.